I'm Dan, and welcome back to the video training series for print reading for construction. We will be discussing Unit 7, Construction Materials Types and Uses. In this unit, we will cover the textbook learning objective bullets along with additional information related to the construction materials. The topics are organized based on the CSI divisions the materials would be found in. Let's get started. Aggregates in general are part of Division 31 earthwork and Division 3 concrete and are widely used in several areas of building construction such as sub-base support, foundation backfill, underground drainage, fill-around pipes, and an ingredient in concrete mixtures. We are mostly going to discuss aggregates for concrete. Here are some examples of gravel shown in plan and section view, not used in concrete. Aggregates for concrete are broken down into two main categories, fine and coarse aggregates, with fine aggregates broken down into sand and pea gravel. Sand is small rounded pieces that are 0.00591 inches to 0.187 inches in diameter, yeah, really small, and pea gravel, small rounded pieces approximately 1/4 inch to 3/8 inches in diameter. And there are generally two kinds of coarse aggregate: river gravel, large aggregates dredged from the river, and crushed stone, mined stone mechanically fractured and graduated to size. Aggregate characteristics: soundness, chemical stability, abrasion resistance, grading and sieve analysis, percentage of crushed, particle shape, surface texture, specific gravity, absorption, moisture content, and volume stability. Division 3, concrete. Concrete was used by the Romans as early as 100 BC. It's a mixture of cement, sand, small and large aggregates, along with water. Its hardening is caused by a chemical reaction between the cement and the water called hydration. The concrete is held in place by formwork until it gains enough strength to support itself along with the loads that it was designed to carry. Most mixtures set in 4 to 12 hours, usually closer to the 4 hours. The hydration process is affected by temperature. The reaction slows when below 70 degrees Fahrenheit, with the reaction completely stopping around 32 degrees Fahrenheit. The water to cement ratio, referenced W/C, determines the strength of the mixture. Excessive water will reduce the strength of the concrete. Most design strengths are reached within 28 days. Formwork can be removed after the concrete sets and gains enough strength to support itself and the loads it was designed to carry. Fly ash is widely used in concrete mixtures today. It is produced when coal is burned to produce electricity. This byproduct can be used as a replacement for part of the Portland cement. There are 5 types of cement. Type 1, normal cement, which is also most common, and Type 2, moderate sulfate resistant, which is slower reacting. And today, most plants use what is labeled Type 1/2 cement year-round. Type 3, high early strength, meaning it gains strength faster. Type 4, low heat of hydration, which means it sets really slow and does not generate a lot of heat during the hydration process, typically used in large mass concrete placements. And Type 5, high sulfate resistant. A typical cubic yard of concrete has 45% coarse aggregate and 25% fine aggregates, with 10% cement. The remainder is 15% of water and up to 5% air entrainment. In almost all concrete mixtures, there is some kind of admixture to improve the quality of the concrete performance. Here are some of the most common. Retarders, which slow the set time down in hot weather. Accelerators that speed the set time up in the cold weather. Water reducers. These make the concrete act like it has more water than it does, which makes the concrete more flowable and placeable. And concrete coloring agents used in decorative concrete. Concrete reinforcement. Concrete has great compressive strength, but is poor in tensile strength. The use of reinforcing steel, rebar, overcomes this weak tensile strength. The deformations on the rebar improve the bond between the rebar and the concrete when hardened. The rebar is set in place during the forming process and prior to placing the concrete. Rebar comes in sizes from number 3s to number 18s. The numbers translate in eighths inch for the bar size number. For instance, a number 3 is a 3/8 inch bar, a number 5 is a 5/8 inch bar, a number 8 is a 1 inch bar, all the way up to number 18, which is a 2 1/4 inch bar. Here, the reinforcing steel rebar is used in a foundation for a column footing on a large commercial building, and here in the concrete wall. Note the steel plate at the bottom. This is called an embed, which will be used for a structural steel connection later in the project. Welded wire fabric, abbreviated WWF, and commonly called mesh, is a prefabricated material used to reinforce concrete slabs. Note, in most cases, slabs with reinforcing are not considered structural slabs. The mesh consists of wires welded together. The W is used to define smooth welded wire fabric, and the D for deformed welded wire fabric. Mesh is shown in section as a dashed line with an X between the dashes. An example of a mesh designation would be 6x6 W1.4 times W1.4. The first two numbers is the wire spacing, 6x6. Then with the W or a D, the W standing for smooth wire, followed by the wire gauges, 1.4. The lighter the wire gauge, the lighter the poundage per 100 square foot. Most contractors refer to mesh using the poundage per 100 square foot. Like the mesh we just discussed, 6x6 W1.4 times 1.4 would be referred to as 21-pound mesh, and 6x6 W2.9 times W2.9 mesh would be referred to as 42-pound mesh, which is one of the most common meshes used. Division 4, Masonry. Typical masonry units used in construction include brick, concrete masonry unit commonly called CMU, clay tile, and stone. These units are built and held together using mortar. Masonry mortar types are Type M, high compressive strength and good durability. Type S, high strength with stronger bond. Type N, general use with medium strength. Type O, low strength for use in interior non-bearing masonry. And Type K, a very low strength. It should only be used for interior applications. Typical types of brick. Adobe, made with earth and organic materials. Kiln burned, made from clays, coloring, molded to shape, dried and fired for hardness. Sand lime, made from mixture of sand and lime, hardened under steam pressure and heat. Concrete, made from Portland cement and aggregates, molded and chemically hardened by hydration. Building, usually referred to as common brick, used inside and outside. Face, manufactured under more controlled conditions to produce bricks of specific dimensions, colors, and structural qualities. Glazed, finished with hard, smooth coating on the face. Fire brick, used where masonry units are exposed to extreme heat. Paving, used on driveways and patios, and can be decorative. When brick is laid up, there are many ways it can be set to create a design and interest in the brick patterns. These have names such as stretcher, header, sailor, soldier, roll-lock stretcher, and you can see on some of these other diagrams how those are laid up in the masonry coursing. Units that make up walls are classified as single width, composite, cavity, and veneer. Veneer being the most common in residential construction. Common masonry units, also referred to as CMU or block, are made up using concrete filled molds that come in large variety of shapes and sizes. Note, even though a block is referred to as a 8 by 8 by 16, the actual size is 3/8 inch less to take into account for the 3/8 inch mortar joints. Referenced here are some of the typical sizes. CMU block are the backbone of much masonry commercial construction. Structural clay tile. It is similar to brick, but a larger unit with rectangular open cells. It has load-bearing capability. It can be used for backup for curtain walls and fireproofing of structural steel. Typical stone materials would be granite, limestone, marble, sandstone, slate, and any kind of cut stones removed from a quarry. There are many stone patterns. Here are a few. Rubble, stones laid in a irregular pattern with varying sizes and shapes. Ashlar, which is a squared edge stone laid in a variety of patterns, as seen in the legend. And cut stones that are cut at the mill to dimensions and laid according to the designer's pattern. Here are some typical masonry symbols. When viewed in elevation, they are somewhat representative of the pattern it is to be laid in, and when viewed in section, it is typically delineated using a variety of crosshatches. Division 5 metals. Too many to mention all the applications, but here are a few. Beams and joists, metal studs, windows and doors, roofing supplies, plumbing, and hardware. Metals are generally classified as ferrous metals, which contain iron as a principal element, usually have magnetic properties, most common iron and steel, or non-ferrous metals, which contain no iron, has no magnetic properties, typically lighter and less strong than ferrous metals. Most common are aluminum, copper, brass, bronze, etc. If desired, the surface of metals can be treated, like chroming, which is a chromium applied as a finish to the metal surface. Galvanizing, a coating of zinc on iron or steel to resist rusting. Rusting, a protective coating of rust forms on certain kinds of steel like core 10 steel. And electroplating, adherent metal coating applied by means of electrical current. Metals with a thickness less than 1/4 inch, also known as sheet metal, is commonly referred to in gauges. Gauges range from 4, the thickest, to 38, the thinnest. Note as the number gets larger, the thickness gets smaller, as seen in this representative sample of gauges. 4, 6, 8, 10, 12, 14, 16, and so on. Also note the weight is in per square foot of the material. Also included in Division 5 metals is structural steel, metal joist, metal fabrications, and decorative metals. We will discuss structural steel shapes in this unit and metal joist in Unit 11, Structural Prints. Structural steel shapes. The term is applied to hot rolled steel sections shapes, and plates. A common structural steel shape would be a wide flange beam. An example, W12 by 16. The nomenclature W is for wide flange. The 12 is for the depth of the beam, and 16 is for the weight per lineal foot. Here is another example for an angle. L indicating the angle, and the 3 by 3 would be the length of each leg, and the 1/2 inch would be for the thickness of the material. Note additional designations for structural steel shapes, such as M, the miscellaneous shape, S, American Standard beam, C, an American Standard channel, L, angles, both equal and unequal legs, WT, a wide flange T-shaped member, MT is cut from a miscellaneous M shape above, ST, structural T cut from the American Standard beam, and Z, a Z-shaped piece of steel. I've only seen this used in elevator shafts. I'm sure there are many other uses. Now let's talk about wood in Division 6. Wood has a reasonably high compression and tension strength and is used for structural framing. This would be classified as rough carpentry, such as building walls, floors, roof trusses, typically seen in residential and light commercial projects. Wood, when used for trim, doors, kitchen cabinets, shelving, would be called finish carpentry. Woods are classified as hardwoods or softwoods. Hardwoods would be ash, birch, cherry, hickory, maple, walnut. Softwoods would be like Douglas fir, fir white, pine, pine white, redwood, or spruce. Lumber is classified as rough sawn or surfaced, as seen in the picture to the right. Rough sawn means it has been cut to a rough size but not yet dressed or given a smooth surface, while surfaced means the wood has been dressed by a planer to provide a smooth surface and dimensional uniformity. S2S means finished on 2 sides, and S4S means finished on 4 sides. Plywood. Plywood is made up of multiple layers. Each layer is at right angles to the previous layer. The layers are bound together using glue. There will always be an odd number of layers, so that the grain on both sides of the plywood will always run in the same direction. Panels typically range in thickness from 1/8 of an inch to over an inch. Plywood uses are numerous, such as concrete formwork, sheeting on floors and roofs, and is widely used in finished carpentry. Glue laminated timbers are a heavy structural wood member also included in Division 6. Glue lams are made up by the process of laminating layers of lumber together with adhesive. This process has made it possible to span large distances. Wood columns, beams, arches, and other members of nearly any size and shape can be fabricated. These laminated products are made of kiln-dried lumber and prepared for interior and exterior use. These members are usually pre-finished at the factory and delivered to the job site in a protective wrapping. Plastics, also part of Division 6, has many uses in construction, like plastic laminates attached to plywood for countertops, window casings, door veneers, wall surfacing, plastic gutter and downspouts, drainage pipes, including trim and ornamental moldings. Thermal and moisture protection would be Division 7. Materials included in this division would be roofing, damp-proofing, waterproofing, thermal protection, weather barriers, flashing and sheet metal, fire and smoke protection, and joint protection. Thermal protection is called insulation, and it is used to reduce thermal transmission. It comes in many forms, such as bad insulation, which is flexible, loose fill or blown in, reflective, which has a foil film on one side, and rigid, which can be either structural or non-structural. All insulation is resistant to thermal energy transfer. It uses the R value rating systems. Examples of a few materials would be 3.5-inch batt insulation, an approximate R value of 13, 5 1/4 batt insulation, 17, 10-inch cellulose or blown in, 30 plus, 1-inch rigid insulation, 5. As a side note, let's discuss how to calculate R value of a building section. First, list out the materials in the cross-section. Then, find the R value of each material type in the cross-section. Add air films, 0.68 for the inside and 0.17 for the outside air. Total air film value, 0.85. Finally, add them all up for the R value of the section. These values are used to calculate the energy needs for building, structure, heating, and cooling loads. For more detailed list of R values, search the internet. They're easy to find. Division 8, openings, which include doors and frames, specialty doors, folding doors, entrances, storefront and curtain walls, windows, roof windows and skylights, hardware, glazing, and louvers. Glass, a ceramic material formed at temperatures above 2300 degrees Fahrenheit, made from silica sand, soda ash, which is sodium oxide, limestone, which is calcium oxide, and other chemicals like dolomite added for strength, and cullet, which is recycled glass. Float glass, the most common, over 90% of the world's glass used, is made with a continuous ribbon of molten glass flowing out of a furnace that floats on a bath of molten tin. The irregularities then melt out and it's fire polished and annealed. Other types of glass: bent glass, heated and annealed glass pressed over a form; safety glass, tempered, laminated, or wired; insulated glass; patterned glass; and stained art or cathedral glass. Finishes, Division 9, is typically the visible surfaces in construction, like carpeting, gypsum wallboard, ceramic tile, paint, acoustical tile, and many, many more. Too many to mention all and cover in this unit. The finishes on almost all construction projects are outlined in the room finish schedule and further described in the specifications. It is one of the most difficult divisions to estimate due to the many products and surfaces covered in the building. Here is a list from CSI of some of the major categories included in Division 9. I am not going to read them all, but we will discuss some of the materials as we go through this video. Plaster and gypsum board. The more common name for gypsum board would be drywall. Common types of drywall used on a project would be regular drywall, moisture resistant, which resists the absorption of moisture, used in bathrooms and moist environments; foil backed to reflect energy; fire resistant, also called type X, very resistant to extreme heat; abuse resistant, has a graffiti resistant coating; soundproof, resists the transmission of sound through the material; cement board, used where excessive moisture may be present, like ceramic tile backing in a shower stall. Also, note that drywall comes either square or tapered edge. The most common thicknesses are 1/4, 3/8, half, and 5/8 inch. Note, they make other thicknesses for special circumstances like elevator shafts. Tiling is another popular wall and floor finish. We all know ceramic tile, but there are many others like quarry tile, pavers, glass mosaic tile, metal tiles, stone, concrete, brick, conductive tiling used to resist static electricity shock. There's also waterproof membrane tiling and chemical resistant tiling. Tiling, when installed on plywood, will typically have a cement board underlayment, then set using adhesives. When installed on concrete, it is important that moisture is not present and the surface is not hard troweled to the point that the bonding agent will not adhere. Flooring. There are too many types of flooring to even try to mention them all, but the three most typical ones seen in construction are wood flooring, resilient flooring, which is classified in these categories: VC, vinyl composite; VCT, reinforced vinyl tile; LVT, luxury vinyl tile; SVT, solid vinyl tile; and of course, we're all familiar with carpeting. The last category we will discuss in this video is Division 10, Specialties. It covers such materials as visual display units, signage, partitions, wall and door protection, toilet, bath, and laundry accessories, fireplaces and stoves, safety specialties, storage specialties, and flagpoles. Here are some examples of building material symbols used in elevation and section. Note, additional material symbols can be found in the reference section on page 347. Let's summarize some thoughts on being green. Reducing lumber waste. Use pre-cut, custom, and fabricated components, which will reduce lumber waste on a project. Use high-efficiency windows. Windows and glass can leak a significant amount of heat in the winter. Installing high-efficiency, triple glazed windows in cold climates can reduce heat loss by 15 to 30%. Volatile organic compounds, VOCs, are toxic substances that evaporate into the atmosphere. The evaporation of VOCs contributes to the development of environmental hazards such as smog, but VOCs also reduce the air quality indoors. Not only are VOCs harmful to the environment, but they can also be harmful to your health. Plan to use zero VOC paints. Choose carpets and other flooring materials carefully. Take the time to research the materials. Now it's time to test your knowledge. We're going to be looking at Unit 7, pages 131 to 133. Pause here and review the material in Unit 7, then answer the questions. When complete, continue the video to see the answers. Repause the video and review your answers. This completes Unit 7.